I thought I'd pull out a quote here. This is from Taylor Swift. This is her math era, I guess. And if they don't like you for being yourself, be yourself even more. You don't have to make that many compromises to succeed. It's okay to be an individual. And so we like you for who you are. But please do study. All right. Now, what's our goal for today? Now, if you think back to last time, we talked about annuities. And so the idea of annuities is instead of one payment, we say, well, what's happening to that? We're going to make many payments. And we looked at the problem. It says, okay, suppose you've made many payments over the years. What's your total accumulated to at the end? In other words, we talked about future value. But we can turn it around and say, well, suppose we have to make many payments, but now instead of saying, what is it going to be worth at the end, say, well, what is it worth to me today? In today's dollars, what's the present value? Now, the process of answering this question is the same. So we're not going to go through the derivation. It is in the handout if you want to see it. But essentially, you have these individual payments. And now you just say, okay, instead of looking what is it worth at the end, you run it backwards. How do you run it backwards? Well, instead of multiplying it by 1 plus the interest rate times to the power of the number of periods, that runs it forwards. You take 1 plus the interest rate to the power of number of periods to go back. So there's negative exponents. So that's the big difference. Derivation, otherwise, in principle, same ideas. So it leads to a formula. I can find the present value if I say, what's the payment I make at each time? So we make this underlying assumption, it's always the same payment. 1 subtract 1 plus I to the negative n over I. So sort of, you'll notice here, there's a negative upstairs. This ties into what's called amortization. And which, it's fun, they point out something. If you look at this word, there's this sort of piece of it, mort, you might see in things like mortuary, mortician, things dealing with death. Well, the idea of amortization is you want to kill off a loan, kill off the debt. So you say, okay, I have a debt. Somebody's loaned me money. That's the present value. That's the money I have. And then I'm going to pay it off over time, but of course there's going to be interest I have to charge. And then the question is, if I make n payments, they're all equal, and I have an interest rate, what should the individual payment be? And this is the formula. And if you look at these two formulas, they're the same formula. The only thing that you've done is just move this across. So this figures out, okay, how much do I have to pay off in every payment to pay back a loan? All right, so that's the theory. And that's, as far as theory goes, that's what I want to talk about. Are there any questions before we get into some practice? All right, we'll get into some practice. I will say that when it comes to practice, I'm heavily biased towards word problems because I do think these are going to be useful to you to be able to recognize how do you transition from word problems into mathematical formulas. If you get nervous about word problems, don't worry too much. The exam, at least based on what I've seen from the practice exam, there's very minimal lengthy word problems in there. All right. So, first question. What is the present value of an annuity that pays $400 a month for 10 years if money is worth 5% compounded monthly? And that's such a strange way to put it. I don't know if I got this phrasing from the book or I just I'm not very good at writing words. You should think of it as like, there's inflation, 5% interest, or 5%. And sometimes 5% sounds almost pretty good. But okay. One of the things you want to be able to do is distinguish present value versus future value when it comes to annuity. Now, we know it's an annuity problem because they say annuity. We know it's a present value problem. What's the clue that gives it away? Because it says it. Sometimes word problems are pretty direct. And if they tell you something, believe them. All right, so we say, okay, we've got a present value, there's an annuity, and so we say, let's write down our formula. So present value, it's our payment times, and then it's 1 subtract 1 plus I to the minus n over I. So we need to figure out the pieces. Now we know what we're solving for. We know we're solving for present value. So this is what we're trying to find. So we need to figure out a few things. Namely, what's the payment, PMT? What's I? What's N? Okay, well, we see some numbers floating around. So we see a 400, a 10, and this 5%. So let's think about where these pieces fit in. 400, does that match with one of our pieces? Which one? I see heads nodding, yes. Where does it go? Payment, N, or I? It's the payment. So it's how much we're getting in each period. All right, well that's good. 10 years. Okay, so where does this fit in? So, is this N, and why not? Yeah, notice the time phrase, you have to check. How often are we compounding each year? And that affects N. So that's part of the formula. So it's not just the number of years, it's the number of times you did something. So in particular, we paid $400 not just once a year, but we paid it every month. So that's 12 times a year for 10 years. So N is 10, which is the number of years, times 12. Because there's 12 months per year. So that says N is 120. All right. Good. That leaves us with one thing left, which is I. Well, there's one number we haven't used, this 5. So how do we turn this 5% into the I that we need? Yeah, so first thing, we can't use it as a 5%. We've got to convert it to a decimal. So 0.05. But remember, this is the interest rate per period. So this is per period. So for us, we're doing monthly, so this really should be per month. And if you look, it does say 5%, but it's compounded monthly, which means it expects you to do it 12 times a year. So you break up that 5% into 12 equal pieces. So that's 0.05 over 12. And that also accounts for that other I. And we put it all together. And we say, okay, so now that we have our pieces in place, our present value, how much it's worth to us today is 400, 1 subtract 1 plus 0.05 over 12 to the negative 120, divide by 0.05 over 12. And then we'll need to get a calculator. So let's do that. We have a calculator here. So get used to typing things in. Know how to type your pieces in. 1, subtract. I always encourage people to be very generous with their parentheses. 0.05 divide by 12 to the power minus 120. And okay, there's the numerator. Divide by 0.05 divide by 12. That's what happens when you don't have enough parentheses. Okay, let's try this again. Times parenthesis 1 minus parenthesis 1 plus 0.05 divide by 12 parenthesis to the negative 120 parenthesis divide by 0.05 divide by 12. That's okay. Now I'm being annoyed. I'm going to give myself one more chance. I believe in myself. I believe in the ability to use calculators. Maybe I shouldn't, but I want to believe. I want to believe. 1 plus 0.05 divide by 12. Okay. Delete, delete, delete. I know you're like, ooh, this is not very exciting to watch me type things into the calculator, but maybe this is the kind of problem we were never meant to know. No. We were meant to know these things. 0.05 divide by 12. Okay, come on, calculator. Do it for me at least once. I have no idea why this is giving me a syntax error. Is anybody else having better luck with their calculators? Did you have a number? What? You don't know if it's right? Well, it's better than me. I know syntax error is definitely wrong. 37,000? 712.54. Okay. Well, let's reason whether or not it's right. So, does it seem like it could be right? Well, first off, how much money are we going to end up making? You know, these $400, there's 12 payments a year, 10 years. So how much money goes into this annuity or comes out? However you want to view it. Ignoring interest, how much comes in or out? 48,000. 400 times 10 times 12. Now, should you be less than 48,000 or more than 48,000? Just reason. Would you rather have $1,000 today or someone tell you, I'll give you $1,000 next year? Which one is worth more to you right now? The $1,000 today. Money that people are going to give you in the future is worth less to you today. So $48,000, most of that comes in the future. It should be worth less to you than just the blank payments. So being less than 48,000 is a pretty good sign, and it's in the ballpark. All right, so if you had gotten something above 48,000, definitely mistakes were made. If you had gotten something that was ridiculously low, $25, no, it's definitely worth more. So, yes, reason. Okay. All right. I'm going to have to take a calculator class, it looks like. I should have asked, were there questions? Other than you're probably like, how could he not know how to use a calculator? Well, I'm so used to teaching without one. So, all right. My apologies. You sell your car to someone and agree to finance it at 1% per month to pay the $3,200. Okay, so it's not a very nice car, but that's all right. It works, it runs, it's worth a few $1,000s. How much should you receive each month if the loan is to be paid off in 18 months? All right. So, let's think about how much should you receive each month? What is it we're trying to solve for here? In terms of things we've talked about. This is the payment. So you're having a loan repaid. So if we go to our formula, now if you don't like memorizing lots of formula, you can always start with the present value formula, which is present value is the payment times 1 minus 1 plus I to the minus n divided by I, and rearrange this to say, okay, the payment is the present value times I over 1 minus 1 plus I to the minus n. All right. So with that in place, say, okay, we're trying to solve for the payment. So this is what we're trying to solve for. Well, now we need to find our other pieces. So let's talk about our other pieces. We have this 1%. We have this 3,200. We have this 18. What's the present value? It's the amount that you financed. So that's the $3,200. All right. What's the n? How often are the payments being made? They're being made per month. Right? You should receive it each month. You're paying it off in 18 months. So n is what?
18.
N is 18. Now, what is I? So I, be careful here, it's 1%, but it's not 1% per year, it's 1% per month. Well, the good news is we're working in months. So remember that I is the interest rate per the period, and our period is 1 month. So our I, in our case, is going to be 0.01, because each month is 0.01% interest. So 0.01. So this makes it 3,200 times 0.01 divided by 1 subtract, and 1 plus 0.01, I can do that math in my head. That's 1.01 to negative 18. All right, okay, I really hope I can do this one. Okay, come on. Come on, calculator, don't embarrass me many times in a row. 3,200 times 0.01 divide by parenthesis 1 subtract 1.01 to the power minus 18 equals, all right, it must not like, okay, 1.01. You're probably like, wow, see, it's trying to learn to use this calculator in real time. That's right. Pro tip, learn to use your calculator before going to the test. Okay, all right. I think it's not liking the negative in the exponent. Minus 2. I don't know why it doesn't like the negative in the exponent, but that's this calculator. Okay, so now I know how to fix that. 3,200 times 0.01 divided by 1 minus 1.01 to the power I'll take 0 subtract 18. Ha ha ha. Shouldn't have to do that, but. And we get $195. We'll round to the nearest cents. So $195.14. Now, technically, the last payment will probably be like $195.10 or something, or $195.20. That often happens on loans. All right, is it reasonable? I mean, that's always a question you should ask. How would you tell if it's reasonable? Well, how many payments are we making? 18. So let's just figure out how much we're paying for this car. This says that our payments, so we're going to pay $3,512.52. By the way, how much of the money that we pay back is going towards interest? Is there a way for us to figure that out? Yeah, so if you subtract 3,200, you see that there's 3,200 this is sort of going to the principal, and I don't know which way you spell principal in this case, and $312.52, this is going to interest. And now you just ask yourself, does that seem like a reasonable amount of interest to pay? Because most of us have had to deal with debt at some point in our lives. Or we're learning to deal with debt because maybe we're just finally starting to learn how credit cards work. But the point is we can say, hey, is this reasonable? So if we've gotten a ridiculously huge number, it's like, oh, I'm paying $40,000 in interest, we would know something is very suspicious. That or perhaps we're loan sharks. But so we know how to make things work. All right. Any questions? Okay. So many problems, so little time. All right. An online lending service offers an auto loan. I guess this book knows its audience. It caters to people who want to buy cars. So an online lending service offers an auto loan for 36 months at 7.5% compounded monthly. If you can't afford to pay $400 a month, then how much can you borrow for the car? Okay. So we're looking for a dollar amount. How much can you borrow for the car? If we write down our formula, we have our present value. We'll keep writing this down. If we write this down often enough, it will become second nature to us. 1 plus I to the minus n over I. What does this correspond with? What is this, how much can you borrow for the car? Where does that fit into the formula? And sometimes you can probably say, well, what do we have? We have a couple of terms. There's 4 pieces, right? There's the present value, the payment, the number of periods, and the interest rate per period. Process of elimination, you can just sort of think of like, okay, the 36 months will tell us about which of these things. It'll tell us about n. This interest rate will tell us about what? I. This $400 a month payment will probably tell us about what? Payment. So what are we looking for? Well, we're looking for the only thing we haven't talked about, the present value. So what's happening is we're trying to figure out, hey, this is how much we can afford to pay. How much can we afford to borrow? And that's the amount that they're going to give us. That's the present value of those $400 payments made over the next 36 months. So I've already talked about a bunch of these pieces. The payment is here, that's 400. The N is 36 because we're paying monthly, 36 months, 3 years to pay off. How do we find I? Yeah, so it's converted to decimal, 0.075, right? You move the decimal over 2 places. So there's going to be an extra 0. And this 7.5%, the implicit thing is if it doesn't specify, it's per year. Because a 7.5% interest per month is pretty steep. That's a very steep. So you take the 7.5%, that's your yearly, but then you say, but how often do you compound it? We can compound it monthly, so we divide by 12. Okay, so we have 400, 1 minus 1 plus I to the negative 36, divided by 0.075 over 12. Whoops, I should have written here 0.075 divided by 12 is I. Okay, well, let me rewrite that again. 400, 1 subtract 1 plus 0.075 over 12 to the minus 36 power divided by 0.075 over 12. Okay. So, there we go. And let's try to type this in. So 400, whoops, 400, not 4,000. That's a very steep car payment. Or maybe that was a very nice car we bought. And make sure you're typing things in right. That's why it pays. It pays to check that you got the answer you think you should get. 0.075 divide by 12 to the negative 36. Let's see if it likes this way. Divide by 0.075 divide by 12. All right. And the answer is $12,859 and 16.5 We'll round it up, 17 cents. So we can get 12,000. That's I can guess a really nice used car. All right. Well, is this reasonable? Just, if nothing else, think, would you make this deal? What's one thing we could compare it to? Well, you could take the $400 a month for 36 months. And that says you're paying $14,400 over the next 3 years for the ability to have $12,859 today. And again, these are reasonable numbers. So you're paying a little bit more over time to get money today. All right. Any questions? I finally figured out that there's this minus button on this calculator that stands for negative. I was using the minus button that stands for minus. Turns out my calculator doesn't like that. Ha! Who knew? Wow. Calculators are so picky. All right. Let's do at least one more. Maybe 2 more. The annual interest rate on a credit card is 18% compounded monthly. It's not actually a bad rate. If a payment of $100 is made each month on an initial balance of $3,000 and no additional purchases are made, how long will it take to pay off the card? So we have $3,000, we're paying $100 each month. How long will it take to pay off the card? Now, before we start, can we say anything about the answer? It'll be what? I'm sorry.
I was just saying you're looking for the amount of time.
Right, n is the amount of time. Can we say anything about how long n should be? So we're paying $100 every time. There's a $3,000 debt. how large should n be? Like, what's the minimum possible? If there were no interest at all, how long would it take? So if you had $3,000 to pay off and you paid off $100 each time and they said, forget the interest. I like you. You're a nice person. How long would it take? It would take you 30 payments, right? 3,000 divided by 100. But they're charging us interest because apparently they don't think we're that nice. So our answer better be above 30. So it's one of those things like, okay, again, you have some intuition about how things should work. Now, let's write down our formula. Well, we have our present value is our payment. 1 subtract 1 plus I to the minus n, divide by I. Now, this question asks, how long will it take? What are we trying to solve for? N. Okay. So we're solving for something a little different here. Previously we were solving for, we're solving for payment, or we're solving for present value. Now we're solving for n. And before we even get too far along, what tool are we going to need to answer this question? Log! Yes! Yes! Why do we need to use a log?
Bring it down.
To bring it down, right. It's got to come down. Right now it's upstairs. We got to bring it downstairs. So, logs are in our future. All right, well, let's talk about the pieces we know. Present value, what does that match with? The 3,000. It's the current debt. That's what you have to pay off. The payment, what is that? 100. And what is I? I 0.18 divide by 12. So it's 18% is your yearly interest rate, but they compound that monthly. Okay, so 0.18 divided by 12. I feel like we could probably make that a little bit cleaner. Does that clean up nicely? I'll use a calculator, pretending like we need a calculator to do that. So 0.18 divided by 12 is 0.015. All right, so we have the following. I'll rewrite it again. 3,000 is 100. Then we have 1 subtract. 1 plus 0.015 is 1.015 to the minus n, divided by 0.015. Okay, we got to start moving things around. Ultimately, our goal is to get n by itself. Because if we can get n by itself, then we've won. That's what we're solving for. So how do we get there? Okay, we can divide by 100. Do that to both sides. And so then that gets rid of the 100 there. You can get rid of some zeros there. So 30 is equal to 1 minus 1.015 to the minus n over 0.015. Now what can we do? So again, we're just sort of like stripping things away till we just get down to something very simple. We want to get down, ultimately we'd like to get down to this on the right-hand side. We just want to get to something with the piece that we want in the exponent. So we need to get rid of these pieces here. What's next? Yeah, let's multiply both sides by 0.015. And out of curiosity, since I have my calculator here, that makes this left-hand side 0.45 is equal to 1 minus 1.015 to the minus n. Well, let's swap places. So 1.015 to the minus n is 1 subtract 0.45, which is 0.55. All right. Now we're in a good place. We've essentially isolated the piece with the n upstairs in the exponent. Now we're ready to pull out our tool. The tool being log. By default, I go with natural log, but if you prefer log base 10, that's cool too. Those are the two that are built into your calculators. And notice here, the whole reason we did this is you can bring down the minus n. So minus n, natural log of 1.015 is equal to natural log of 0.55. We're so close. Now that the n is out, we just need to get rid of the things that are multiplying it. So divide both sides by a negative. And so that tells us that our answer, if we come over here, n is equal to negative log of 0.55 over log of 1.015. Now that's obviously not going to be what we put into the box on a homework assignment, or when we call our parents like, oh, good news, it's only going to take me log of 0.55 over log of 1.015 to pay off my student loans. And like, what? No. You want numbers. You might be a little bit nervous. You might say, hold on a second, Steve, this doesn't make any sense. How can it take a negative amount of time? Or does it? So one of the properties of logs, we didn't really delve into this much. It turns out that if you have a number between 0 and 1, and you take the natural log, or log base 10, you get a negative out. And if it's bigger than 1, you get a positive out. So even though it looks negative, it won't actually be negative because you have that 0.55. Okay, so let's try this out. We'll take negative natural log of 0.55. Oh, whoops. Sorry, I was trying to use the answer to the previous one. We don't need that. All right, so negative natural log 0.55 and divide that by natural log 1.015, and out comes 40.1539 ... But what do we do with this number? Well, you have to round it up. So it's going to take us 41 months. Now remember, 30 months was our answer if we said, if no interest at all was charged, it would be 30 months. So we knew the answer had to be above 30. And so 41 is not too unreasonable. That seems all right. Okay. How are we doing? Should we do one more, or should we just talk about the basic formulas we've been talking about for the last week and a half or so? One more? All right, maybe we'll talk about our formulas. Okay. So when it comes to what we've talked about in the last few weeks, we've talked a lot about financial math ideas, but most of it comes down to understanding what's happening with the money. You know, it's growing. How do we take into account interest? How do we take into account one payment versus many payments? And so we have a couple of ideas. Well, maybe we have a single payment. We make just one payment, and we'll have simple interest. In other words, it doesn't grow on itself. It's just, we pay it off. There's a one-time fee. More commonly, what you'll see is that there's something called compound interest. And in compound interest, we say, well, we're going to have the money compound on itself, which means that we're paying interest on top of interest. So that the longer you wait, the much faster it grows. It grows much, much faster than simple interest. And so you have a couple of things. You have the rate, which is usually given as rate per year, and then divide by m. M here represents the number of times you compound, then to the mt, and that's the number of periods that you compound. So using what we've been using more recently, I is the interest rate per period, that's R over M, and M times T is N. Now, that's if you break things up into discrete periods. You might have a quarterly, you might have semi-annually, you might have monthly, you might have weekly. But there's also this idea of, well, never stop, never stopping. Always earning interest, continuously compounding interest. And so that gets us to the formula. The amount that we have is the principal, or if you like, the amount you start with, the present value, E to the interest rate times T. And when we talk about interest rate, we always convert percentage to decimal. We also talked about the annual percentage yield, which says, well, can we just give a simple number? What if we pretended like it was just once a year, what's the equivalent interest rate? So mostly these formulas dealt with, we had one payment initially or one payment at the end. What can we say? What if we had multiple payments? That gets us into annuities. And so we had two cases, the future value and the present value. And you'll notice they're very similar. So what's the future value? It says, look, I'm saving up for something. I put in a little bit every month, every quarter, whatever it is. How much will I have in the future, assuming I have a fixed interest rate? So you add up the little values, which is done by that geometric sum, and you get the answer. The future value is how much you put in every period. That's your payment. 1 plus I to the n. I is your interest rate per period. N is the number of periods. So 1 plus I to the n minus 1 over I. On the other hand, I say, well, maybe I have to pay something back. Or what's the present value of this annuity? So it's essentially running backwards. So you have your payment, but now it's 1 plus I to the negative n. So 1 subtract that over I. One of your big tools you have is that you have reasonable heads on top of your body, right? You understand numbers. You've dealt with money. Don't just blindly type numbers in to the answer. You should question, does this make sense? Now you're probably thinking, okay, but Steve, what do I need to know? Which of these formulas might show up? Well, if we go by the practice exam, you'll need to understand how to compute something like a simple interest. So you should make sure you understand how that one works. You might need to, well, again, by the practice exam, you have a compounding interest over a period. So you should have that one where it's a discrete number of periods. But you might also, again, according to the practice exam, need to do a continuously compounding type problem. And on a side note, the one on the practice exam says you have to solve for something in the exponent. So know your logs. You're like, okay, well, all right, I can live with that. But we're not done yet. You'll need to know how to compute future value. Saving up money for a big payment. And you'll also need to be able to compute present value. These are the formulas you need to know going into the exam. if you're looking to ace the exam, and I want you to ace the exam, it makes our life so much easier when everybody gets A's. That's what you need to know. So the good news is, I couldn't see anything with annual percentage yield. But the other news is, there's lots of pieces. So make sure you know your pieces. Make sure you can put them all together, know when to apply them, know how to apply them. They'll be fairly straightforward. There won't be a lot of surprises. But if you don't know the formulas, you're not going to be able to make much progress.